group that just show up and want to,
Mm-hmm.
even if they were in the sports bar last night.
I know it, right? It meant this one always comes.
Nice.
You know.
gosh, look at this group.
I know.
It's a huge group today. All right, guys, hello, welcome to Tuesday. I thought I would just leave up some fun, interesting things that my seniors were working on this morning, just to give you a taste of where your algebra skills are going to take you. Doesn't that look fun? Isn't that like the most, but look at the answer. The answer is -1. Isn't that the most beautiful answer, the most crazy problem you've ever seen?
No.
That's eventually what you guys will be doing. No, thank you. All right, remember you guys will need a calculator and a pencil today.
I
like this.
We are gonna be working on our graphing practice. So, Jacob, let me grab you one.
I really think you guys we should just do what's on the board today, right? Dustin says yes to the craziness.
No.
Not yet. Not yet. All right.
Okay, if you make
All
us
right.
do that.
It's so much fun though. This is like Sudoku from like all of the math teachers are like, oh, this is so much fun. You love it. You'll love it too when you get there, okay? I promise. I promise you'll love it when you get there.
Are you sure? Or will we just pretend that?
You might say, I'm gonna like it just because Mrs. Telfer said I like it. I think that might be how it works. All right, guys. We're gonna spend all day today just wrapping up and finalizing our quadratics. So remember how this is gonna work. This is the first time in this class where we've asked you to put a whole bunch of things together. So in 6th grade, you started doing diamond problems. And you didn't know why. For the last 3 weeks, you've been doing factoring, and you weren't exactly sure why. Now you know why all of these pieces exist. So we're going to do the first one together. I'm going to remind you about some things, and then we're going to have you just try a few. How do you find the y-intercept? What is unique about the y-intercept? Yes, Cheyenne. Beautiful. You have to put in the zeros where the x's are. So I'm going to put in a 0 everywhere I see an x, which is actually really nice. The y-intercept is the easiest because when I put in zeros for x, what do I get? 0. Oh, I get zeros for some of it, but overall, what do I get?
5.
5.
You need lead?
But remember, this is a coordinate point. Please put this in as a coordinate point and then graph it. Okay. Boom, done. Y-intercept, super easy. We got it. How did we find the x-intercepts yesterday? What did we have to do? What do you guys think? What do you have to do to find out those x-intercepts? Jacob, you started it. What are you doing there? Making the box and the diamond. It's known as factoring. So this is not helpful. This is known as the standard form of the quadratic, and it's not helpful to find the x-intercepts. So I'm going to draw myself a little line here, and I've got to find my x-intercepts. All right, so I make just like what Jacob's doing. I'm going to make my box and my diamond. I have an x squared. I have a 5. So what multiplies to 5 but adds to 6?
1 and 5.
Yeah, 1 and 5. It is so tempting, guys, to say 2 and 3. I know, because you see the 6 and the 5, and you're like, oh, 2 times 3 is 6. Be careful. What multiplies is up here. What multiplies to 5 but adds to 6? Yes, that is our 1 and our 5. Okay, I'm going to put my 1 and my 5 here. And remember, we're trying to find our base and our height of our rectangle. So this becomes x and x. I get a +5 and a +1. So when I write this in factored form, I get x + 5 and x + 1. Remember, this is the area written as a product. This is the same thing as x squared + 6x + 5. Okay, it's just written in a different way. Please, at this point, be careful. Don't say now, oh, my x-intercepts are 5 and 1. Done. Be careful. Because remember, the x-intercepts is when y is 0. I'm trying to make that equation equal 0. So the question you're asking yourself is what numbers will you put into x to make that true? So let's talk about this first guy. Before I do the mathematics, I want you guys just to think about it logically. What would I plug in right there to make that chunk 0? -5. So I know I have a -5 somewhere there. What would I plug into this guy to make that chunk 0?
-1.
-1. So you now know your x-intercepts. Now I'm going to do the math behind it, just so you can see what it is I'm doing. I'm setting each piece equal to 0. And then I'm just solving for x. So I'm subtracting 5, subtracting 5. When I get x equal to 5, come over here. X plus 1 equals 0. I subtract 1, I subtract 1. And I get x equal to -1. There it is. So I know that I have 5, -5, sorry, it's negative, -5, 0, and -1, 0. All right, let's graph that. -5, -1, there it is. Those are my x-intercepts. So I have one point left, and that's the vertex. How am I going to find that vertex? What do you think?
Is it going to end up making a weird shape?
No, it makes a U. All of these make that parabola U. Where's the vertex? Yeah, Cheyenne. In the middle. So here I am. I'm sitting at -1 and -5. What is exactly in the middle of those? -3. So I have my first, and if it helps you, draw your line of symmetry. You know your line of symmetry cuts the parabola in half. That's what it does. So I now know that my vertex, I'm going to draw another line here. My vertex has to go through -3. But remember our question mark from yesterday? Where is it? Is it -3, -9? Is it -3, 7? Is it -3, 5? Is it -3, 4? Where on that line does it go? How are we going to find that out? Yeah.
Yeah, just put -3 into where all the x's are.
Yeah, so remember, thank you, Cheyenne. You're going to take that -3, and you got to plug it right back into there. That's how we work that, okay? So plug -3 back into that and see what you get. What is your vertex? We're going to get y equals -3 squared plus 6 times -3 plus 5. See what you get. What happens? So we'll move that far down. I try to give you ones that'll work. So what happens when you take 9 minus 18 plus 5? So that's what happens here. What do you get?
-4.
-4. So our vertex is -3, -4. Now, Leah, does that help with the picture? Because I know those dots look weird. Does that help? Now, for some students, it's nice to do what's called a symmetric point. And the symmetric point, every point has a mirror image. So if it helps you, you can put in that symmetric point there and draw in your U. There it is. Okay?
Can you wait? We don't let anyone out for the first 10 minutes.
So I want you to go back and find that vertex. Everything else is already except for that vertex. Okay. What I want you guys to do is to try the next one. Try the next one on your own. And when you're done, let Mrs. O'Day and I know, and we'll come around and talk to you about it. Yep. Fantastic. Okay. Go on. Keep going. So we want to know, how are you going to find all these points? It's a lot of work, guys. It's a lot of work. Yeah, so remember, you know that it's going to be, well, and so be careful. I want you to think about this one. These are not the same, okay? So I agree that that works. But when you come here to your box, yeah, you get x minus 5 and x minus 1.
Oh.
But so remember with your x-intercepts, We want to know what values you plug in to make that true. Okay, so. Yeah, you're very close. My freedom.
I don't remember. Okay. So.
Miss Taffa, the Zoom people need the next equation.
Do you want me to?
Sure. Come on now. I got this. I can do it.
Did they? So you're gonna have to use. Okay, now you have to have x by itself. Right now you have x minus 5. So you have to get x by itself. Okay. Yeah, and then nice job. Yep. Just move on. Okay.
Yeah. So what happens when that doesn't work? What do you say?
Okay. So
Okay.
if we're looking at this,
Mhm.
if you just have negative 1.
All right, so girl, hold on points. Yes,
Yeah.
okay. Turn to the next page and try the next two. You do have it. And you look at how worried everybody was.
Okay, so would we have that graph there?
You guys got it. Now, I'll hint you on this next page with the next two. There's one that's not factored.
Oh, so, okay, so it's.
There's one that's not factored. Oh. Yeah, I'm gonna let you discover which one. That is correct. So now think about what would you put in
So
right
now what would
here
you
to
do?
make that 0.
So where is the cemetery?
5 minus 5, so it'll be 5. So you know that one. Okay, so where are you inside?
Okay.
So what do we say if you can't see that? Yeah.
Okay, so I tried to see if I realized it was,
Okay, so be careful. 0, 5 is up here.
that it was,
So that's 0, 5 is up.
that's what the piece is,
Okay.
wasn't in the plastic.
Well, on the line it says, yeah. So 0, 5.
This.
Yeah. Yeah, I'm gonna do this guy for you. This is the second one.
Thank you.
So we're looking at what multiplies to 5x squared positive, but multiplied by negative 6. And I agree that it's negative 5 times negative 1 gives me positive 5. Negative 5 plus negative 1 gives me negative 6. Okay? So, and then you put that here, you get x minus 5 and x minus 1. So remember, that's just the way you write that quadratic in what we call factor form or the area of the product. We need that to equal to 0. To find the x-intercept, you have to set it equal to 0. So what number are you going to plug in right there? Yeah, so positive 5, what number are you going to put right there? So that means our x-intercept and our y-intercept are 5. Okay. And now, that means, you're graphing it like this. Here's our 5, 1. That's 1, and that's 5. It'll look something like that. Okay?
For now.
So go ahead and go on. So, on this guy, we didn't treat it yesterday. So, the first thing is, y-intercept. Okay? Y-intercept is when x equals 0. So, what I want you to do, you can have both of these guys. Plug in x is 0.
Yeah, I think it kind of wrong.
So, all you're doing is plugging in 0. That's the first step. So just start with the first thing in the table and you go from there. Yeah, that's number 1. Correct.
There you go.
So interesting that
Your
the y-intercept
Right,
and
your
vertex
line
are
of
the same.
symmetry.
Right?
Because what's the x you're gonna get your y.
Yeah, so what, is there anything else I think you can do?
I think it's, thing is, you first,
That only gives
because you're forgetting that the eight is now.
So,
They just want to go straight with it.
there you go. Okay, so what do you get when you do? Yeah, you get 5, right? So that means in your table, when you're in your table, your y-intercept is 0.
What do you say when it doesn't work? When you're not able to factor it?
All right, so now our x-intercepts. Our x-intercepts
For
take
now.
a lot lower. Because the way it's written here, you can't, it's when y equals 0, and it's really hard to solve that. What makes it easier to solve is if you factor it first. So you're doing your whole blocks and running. That's to find your x-intercept. So we know the x squared go to the bottom left. We have 5 units, go to the top right. So we know that the diagonals on these boxes always multiply to the same thing. So x squared times 5.
It is factorable.
5 squared, so that's what goes on the top.
It will be.
How many
It will be.
times do we have? Well, we have 6. So now the question is what do you multiply to get 5 to add to 6? So there's only one option here. There's only one choice. It's 0 negative 1. All right. Oh. There you go. Move on to the next one. Oh, it's just x equals 3. It's just that line that goes through that vertex. Yep. All right. So now, what did we decide? Yeah, it's 1x and 5x, right? So I have my 5x here and my 1x here. Nope, it doesn't matter. Yep, so we know we have x here. 5 and 5 is the greatest, so I remove a 5. 1 and 5, the greatest number between there is just 1, and it works. X times x gives me x squared. 5 times 1, what's that? Gives me 5. But now what I've done is I've changed the way this equation looks. It's the same, this is the equation written as a sum. This is the equation written as a product. It means the same
You
thing.
need to do the box
But
and then
this is
all
why
that
we
stuff.
do it. Because now I can set that equal to 0. Because I want to know when y equals 0. So what number are you going to put right there to make this part 0?
So what's on the end of that?
What are you going to put right here to make this part 0? Boom. So now you know your x-intercept. Your x-intercept is 5, 0. And your other x-intercept, or negative, sorry, negative 5, and then another one is negative 1.
Okay.
That's confusing.
And then what?
Well, you're trying to make everything work out to be 0. Now, graph those points and we'll talk about them.
Wait, it's why
Yeah.
So this is your X.
Okay.
You finished. Well, then you're gonna do the whole class. Thank you. I'm going to lunch.
That's right. Oh, he's got it. Be careful on this one. I want you to really think about number 5. It's not pointed downwards. It'll be an upward pointed one. Okay. How we doing? You know? Looks good.
But what is your?
It's hard, isn't it? It is not easy. Yeah.
Oh,
Okay.
please.
There, this one does work, right? Because what's halfway? Yes, it's okay. The vertex and the line intercept can be the same number, the same point. Well, you might not have asked it clearly. What's halfway between -3 and 3?
I said that you needed to do the
Yeah.
box and the diamond, so I did not even go.
There you go, Justin. You gotta find the vertex.
You're right about that one.
We're fighting.
I am right about that one, I know.
We're fighting again.
Oh, I did it wrong.
I win.
I did
I'm right,
positive
Spencer's
2.
wrong.
Sorry.
I'm right.
You feeling good about
Gee, is that right?
it? It looks great.
Oh, you got it.
I literally you copy off all of my.
All right, so keep going.
Wait, so then let's look at the way we're writing.
Yep.
Oh, my
On to the next one.
Wrong direction.
Wrong direction.
Uh-huh. We're gonna come back together as a class and talk about this. But I want you guys just to get.
So we can do that.
Well, I saw
I would have put them as 10 and 2.
That will work.
All right, Jalen, go ahead.
So what do we say when we do that?
All right. So now, how are you gonna find the vertex?
Because we're gonna go.
Yeah, the whole thing has goals.
Together.
Okay, -3. So you know your vertex here. Your vertex is -3 something. And the line of sight is
The
actually.
fortunes can be the same thing as well. As the water.
I don't know.
Well, you
I
said
did.
you gotta plug in -3 into that. So remember, you're just plugging it in.
Oh.
You would say y equals, parentheses, 3 squared. Wherever you see an x, you're plugging it in. Plus 6 times -3.
So
Plus
why is
5.
it wrong? Let's explain this.
Yeah, I don't know how
Okay,
I did it.
All right, Miss Avery. How are you
okay, so,
Okay, so we be careful. You move your box and multiply to 0. So it multiplies to 0, but adds 9. Don't forget your box. Your box is important because you have 1x squared tile and you have 0 unit tile.
Okay.
So you are multiplying to 0, but you're adding no. So what multiplies to 0? What's 0? One of these numbers has to be 0. But now how do I get it to add to? Yes, so there it is. Okay, now you can finish that one. It's okay that one of them is going to be 0.
I still
Is
don't know.
the vertex
So in the
right
box
there
here,
on 0?
yeah.
there's
your
something
X
magical
coordinate
about these boxes that we know to be true, and that is when you multiply the diagonals, they both have to equal 9x squared. So what goes in the top is that diagonal. Because we need it to multiply to 9x squared. But we have, and remember, we wrote it out like this, x squared plus 0x minus 9. You only have, we have 0 x tiles to work with. So what multiplies to -9? That's negative. What multiplies to -9 but adds to 0? Think about, so think about what typical will give you 9. So do your lump on that. Yeah, so we know we have 3x and -3x because 3 times -3 gives me 9. Will give you 0. Yeah. And I'm gonna do that one with everybody in class. I just wanted to see. It's a hard one for that negative option. Yes, it would. So be careful here. Remember, so you're skipping that one important step here. your factors are x plus 0 and x plus 2. But remember, to get your x-intercept, you have to set it equal to 0. Now go through and graph it. It will be a point down. Yeah, it's okay, it's 0. Gonna be 0. No, that's how many you have 2 orange tiles or 2 X tiles.
Oh, yeah.
So what multiplies to 0 and adds to 2.
Is that right? That's
Okay. So this one is factorable.
That's what I've said.
It is factorable. It's this guy. What multiplies to 0 but adds to 2. It works. Think about multiplying to 0. What do you need in order to multiply to 0? One of the numbers has to be what? Okay. Be careful here. How many units do you have out here? Yeah, so that's a 0 out there. It's not 1, it's a 0. So what multiplies to 0 and adds to 2 is your box and diamond. Okay? And it will work.
That tricked me a
I do
little bit.
anything else.
Well, yes, we are going to do something else. We have problems.
I didn't do
When you
anything.
set
So,
it to 0.
Here, so x plus 0, 5 and 1, so we round down 5 and 1. There's 1 and 2, 5 and 2.
Yes.
Now, we know
You have
that the
it.
vertex goes straight through the middle, so where's straight through the middle?
That is so much better, Cheyenne. Nice job.
So now we know it's 3 something, so we take your 3
So set it to
to that
0. X plus 2 equals 0, and then get x by itself.
So you know it's 0, 0. Okay, your other point is 0, 0, but where's this one?
Well,
0,
I think
negative
we're
2 is this one. It's
It
negative
is.
2.
Look what it is, it doesn't have,
0 for x intercept. When Zach comes back.
So I tried putting
So do your
Yes.
best.
as the line of
It is, you're absolutely right.
But it goes to 72.
No, it'll actually, so when you plug in 0, it'll go to negative 9. You're plugging in 0. Your x is 0.
Oh.
So your, yeah, yep, your y-intercept and your line of symmetry, or your vertex happen to be the same number. It's okay, same point, I should say.
So you set it to, you have x plus 2 equals 0.
No,
So how do
so
you get x by itself?
you don't
You
have
have
that,
two.
right?
So
It's just, that is
I have
your,
it here.
you don't have 1, negative 1, 1. It's just gonna be those 3 points. And there's your unit. Now we're gonna talk about this guy, okay? So I want you to think about this. What has to be here? So this is negative. Negative something times what?
What?
Two.
So I did all this work
Plus
just for
6.
I think we have a short cycle this week.
we have a short cycle on Thursday.
Yes.
But that's not that hard. Short cycles are not.
So we're gonna talk about that one. You're really close on that one. You're so close on that one.
And then you have 0, 0, which is what actually is the vertex in the middle.
I'm gonna, yeah, it's a tricky one. All right, guys, finish the problem that you're on, no matter which one. And in about 2 minutes, we're gonna look at question 6. So just wherever you are, it's okay, just finish where you're at, and then we're gonna look at question number 6.
Is this the last one?
Okay, so now you come to your exercise, so see what you can do. So what goes x squared? Now negative 12. So negative 12, when you multiply, you get negative 12 x squared. There is a 0 in it, yes. Yes, the
confusing.
Oh, okay. Now, how many orange tiles or x tiles do you have? You have a negative 8 of them. So I want you to think about what multiplies negative 12, but then adds negative 8. Coincidence, is that? Yes. Not quite. That's why we're going to talk about it. Okay. This one is a trick. was positive 12, yeah, 6 plus 2 would give me negative 8. The only way that could work is that I negative 6. That gives me negative 8. What was negative 2? Yeah, if it was negatives, I would get a positive 12, but I don't have a positive 12, so I get it to be a negative 12. So, it's not factorable. And then I'm going to show you how that works. Oh, it works. It's 8. Okay. All right, let's talk about number 6. So even if you're not quite there yet, if you haven't done 4 or 5, it's okay. I want you, everybody just go to question 6. Because this one is a tough one. What makes this one tough, guys? What do you think?
The x to the second power is a negative.
Oh my gosh, right there. That's the culprit. It has a negative out front. Okay, so guess what though? The way we start this problem doesn't change. The pattern of this stays the same. So first thing I'm going to do is find the y-intercept. Y-intercept is when x is 0. Nothing has changed. All right, so what happens when x is 0? What do we get? Negative 12. So our y-intercept is 0, negative 12. Unfortunately, negative 12 is somewhere down here. There's 10, 11, 12. It's somewhere like right here. Okay. All right, x-intercepts. Also, the pattern doesn't change. I set up my box. I set up my diamond. Okay, but this time, what goes in the bottom left?
A negative x.
Yes, a negative x squared. So I have a negative x squared here. What goes in the top right? Yeah.
Negative 12.
A negative 12. So when I multiply negative x squared times a negative 12, what do I get?
A positive 12.
Positive 12. So I'm here. I know that I'm going to need to multiply by 12x squared. How many orange or middle pieces do I have? How many do I have, Torblit? 8. So what multiplies to 12 but adds to 8?
2 and 6.
2 and 6. Oh, finally, we get to use that 12 and 8. So I have a 2 and I have a 6. Yay, it works. So now I'm going to write out.
I'm not done with number 6. I would be writing this stuff down.
I would absolutely be writing this down. 2x and 6x. Okay. Here's the problem though, guys. This is what makes this one really tricky, is that you have this negative x squared. So when you have a negative x squared, that means one of them, yeah, Cheyenne, has to be what? What do you think?
Negative.
Right, and so it doesn't matter. I'm just going to write it like that. Because I know a negative x times x gives me negative x squared. But here's the dilemma, okay? Well, it's not really a dilemma. You still have to think about it. What goes right here? X times, what kind of 6? Plus 6, because I have x times something gives me a positive 6x. So I know that I have a plus 6 here. What then has to go here to get me my negative 12? Negative 2. Now let's see if it works. Oh, look at that. Negative times a negative gives me a positive 2. Now remember, those are not your x-intercepts. Those are what's known as your factors. You have to set those equal to 0. And you're asking yourself, what do you plug in for x to make it 0? What would we plug in right here to make that 0? 2. 2. Shoo, we've got that one. That's nice. That's a nice one. So we know x equals 2 makes that 0. So one of our x-intercepts is 2, 0. But this one, that's tricky. What? So that's, okay, so you're close. I'm going to set it equal to 0, and we're going to see. How do you take something that's negative and move it to the other side?
You add a positive.
So let's just add this x to the other side. You can move your x's any direction you want. What are you left with?
X equals 6.
Ah, there it is. And that's what makes this one tricky, is because it's actually a positive 6. If I plugged in a negative 6 here, a negative times a negative is positive. So I get 6 plus 6, which is 12. So all I'm plugging in is 6, 0. All right, let's graph all of these points. We've got 2, 0, and 6, 0. Where, oh, where will our vertex be?
4, 4.
4. So I'm going to draw my lovely line here. 4, 4, 4, 4, 4, 4. There it is. So I know my vertex is at 4 question mark. Where is the question mark?
4.
4. So what does that mean about this parabola? Which direction is it facing? It's facing downward. It means that that vertex is a high point. Yeah.
So how do we like identify which way it's going?
Oh, good question. So I'm going to show you the work just in case you're like, wait, how did they get 4? Well, remember, you're plugging in 4 here. Y equals negative 4. Don't forget that there's a negative out there. Plus 8 times 4 minus 12. This becomes negative 16 plus 32 minus 12 equals 4. Okay, that's where that comes from. Now, where is 4 on our graph? Oh, it's right here. 4, 4 is right there. So it looks upside down. Now, Kellen asked a great question. Is there a way we could have known it was upside down before we even started the problem? Okay.
Yeah, so we should have that vertex is at 4. Does that make sense? It's going to be positive. It just has to do with that negative alpha. Okay. So yeah, so you got it, because this would be plus 6. But right here, remember that's a negative x right here. So you would make it that positive.
Good thing to make sure that you get
Okay.
all the information down.
There is a way. So Kellen, there is a way to know where is if it's going to go upward or downward just by looking at it. And it's right here. Right there.
We can't see
You
it.
can see it. It's just upside down. If you have a negative out front, that flips it upside down. Okay? All right, that's a tough one. We'll keep working on some of those, but that's a tough one. All right, guys. Everybody turn to question number 3. Even if you haven't finished the others, it's okay. Question number 3. All right, you guys all came here. You were like, yes, I'm doing this problem. I'm rocking it out. I understand this. I love it. I love quadratics. It's my favorite. And then you get to this. And you were like, raise your hands. This is
Does this work? It's not working. What's wrong?
What's wrong? What's wrong? Okay, what happens right here? It's not factorable. Okay, here is my life. This is where Algebra 1 takes a turn to make it way more fun. Does not factorable mean you can't graph it?
Yes.
I just don't want to
Wishful thinking. All right, let's actually graph this one. So let's see if we can. I'm going to use good old Desmos because I don't want to graph it. You guys are going to get to graph it. All right, here we go. I'm going to put in Desmos here. And if I tell Desmos to graph it and I can't graph it, Desmos will yell at me. But if I can graph it, he'll make a nice graph. So does not factorable translate to not graphable? Ooh.
It happens.
It can happen. So let's take a look at maybe why. What do you think is going to happen with our x-intercepts? You think they're going to be nice numbers? Okay, so let's take a look at it. Ooh, look at that one. That is a negative 1.290. Okay, let's look at the next one. Ooh, the next one is 9.290. Wow. All right, what if I'm going to tell you that you guys have to now find those x-intercepts? Oh, it's going to be a good day for you guys. Okay? Not factorable does not mean not graphable or you can't do the problem. It just means you got to do plan B. So let's talk plan B here, guys. Here it is. Not factorable. If you can factor something, okay, It is the most efficient and easiest way to find x-intercepts. Please factor if you can. It'll make your life so much easier, faster. Trust me, my algebra 3s are still doing factoring because it's easier. But if you can't factor, here's where you have to go. You have to go to what's known as the quadratic formula. Now, in algebra 2, you're going to learn where this comes from. In algebra 1, just write it down and go with it, okay? Don't worry too much about where it comes from. You need a little bit of math to get there. So this is the quadratic formula. And the quadratic formula will get you any x-intercept you could possibly want.
That sounds so fun.
It is. All right, write that sucker down. There is a positive and a negative.
That's disgusting.
It looks amazing. Doesn't that just make you happy inside? Look at how beautiful that is. You will be able to find any x-intercept for any parabola that we give you.
What's the line under the plus?
It's a division. So
Oh.
this is plus minus. So we are going to have a negative b plus or minus the square root of b squared minus 4ac all divided by 2a. The whole thing divided by 2a. All right.
How long do you guys teach this for? Like the quadratic
The
formula?
quadratic formula you will see from now until you finish your math career.
No, I mean like, how long does it take the algebra 3 kids to like learn it and go?
On the algebra 2 kids, you use it so much you're going to memorize it like in a week. Trust me, in a couple days. You use it so much. All right.
I didn't.
The only thing that you guys have to know is what is a, b, and c. Well, everybody go back to your equation.
Okay.
X squared minus 8x minus 12. The a, b, and c are hidden here. A represents the number in front of the x. When we don't have a number, we just say it's 1. Okay, so a equals 1. B represents the number in front of the x. So b equals -8. And C represents your units. How many units do you have? So A is really asking how many purple tiles do you have? B is asking how many orange tiles do you have? And C is asking how many units do you have? Okay? All right, so the lovely thing about the quadratic formula, while it looks intimidating, all you're doing is plugging in the numbers and chugging through it. So I'm going to walk through one of these with you. Negative b. Well, b is -8. Please don't drop the negatives. There's a negative out front for a reason. Okay? Then you're going to do plus or minus the square root of parentheses -8 squared minus 4 times a times c. All over 2 times a. Now, I will promise you, if you do not take the time to write this out, all kinds of funky mistakes will happen. If you try to just put all of this in at once, it rarely works out well. So all I've done so far is I've taken all of my numbers, A, B, and C, and plugged them in. Now I'm just going to do a whole bunch of PEMDAS. Remember good old PEMDAS?
No.
Oh.
Please excuse me, dear Aunt Sally.
Please excuse my, we're going to do a whole bunch of that right now. All right. Here we go. What's a negative times a negative? Positive. So we're going to have a +8 out front. So that's going to be a plus or minus. Now here's my grouping symbol. This is my square root. I've got to do everything underneath that first. So what's a -8 squared?
16. Or no.
Squared. Yeah. 64. Now, what's a -4? This is what 4ac means. You're multiplying. -4 times 1 times a -12. That's what 4ac means. What's the -4 times the a times the c? What do you get?
48.
48. And what kind of 48? Is it positive or negative?
Positive.
Positive. -4 times a -12 is a positive 48. Yeah, negative times a negative.
Oh, wait, no,
Yes,
would
me.
it be? I thought it would be.
Okay. 2. All right. I'm almost there, but I'm still not finished with my grouping symbol. What's 64 plus 48? 112. 12. So I have 8 plus or minus the square root of 112, all of that over 2. Now, is the square root of 112 nice?
No.
Probably not.
Probably not. It's not like the square root of 25. So let's put that into your calculator. 112. Yeah. Ugh. So all I want you guys to do is say, oh, that's just 10.58. Just round it. We're trying to get close. We know it's not a nice number. So here is what it looks like.
Everything is beautiful stuff.
I love this stuff. Okay. Now, at this point, this is just how I make this stylistically. Okay, you're going to see a lot of other teachers do this maybe differently. But in all of the problems that you have graphed today, how many x-intercepts have they had?
2.
2. At this point, you need 2 x-intercepts. This equation gives you 2. And I read it like this. Here's the first one. You have to have 8 plus 10.58 divided by 2. And then guess what you get here?
-9.
Minus 10.58 divided by 2. Okay.
There you go.
When you put that into your calculator, make sure you do the top part first. So you're going to do, the numerator has to be done first. So it'll be 8 plus 10.58, hit enter, then divide by 2. Oh my gosh, there it is. There's that 9.29. You knew that. So there's your 9.29. All right, let's do the other one. 8 minus 10.58.
We'll keep that.
Divide by 2. Oh, there's the other one. How would you guys find the vertex from here? Could you?
I have no clue.
Find the middle of the both of that.
Find the middle. It actually will work out to be nice. But for right now, I just wanted you to see you can find these guys. Did that not make your day that you can find x-intercepts for anything?
No, that was a lot of mental brain power.
Oh,
I would have gone back and there would have been all that on the board. And we turned this in.
no, I want you guys to keep this. You might need it for your review previews.
Right.
Woo! Nicely done today, guys. Nicely done. Okay? That was amazing.
All right, CBBI students, that is the end of our lesson for today. If you have any questions, please reach out. We, again, will have our short cycle on Thursday. We want you to be as prepared as possible. Please make sure that you're doing those review previews, because if you have any questions regarding those, the best time to get them done is before the short cycle. Again, we'll see you tomorrow. Have a great evening.
Well, I sit right next to you.